Let's go back to the documentation for the OnClick listener. As we're starting to realize, Android is very specific about the details around how to listen for an input event. The method can't be named anything else. It needs to be precisely onClick and have exactly one input, which is the view being clicked on, and have no return value. So you can think of this outline here of the onClick listener regarding the class and the methods as a contract that you as a developer need to follow in order to be notified of the click events. In more formal Java terms, this is the definition of an interface. At the top of this documentation page, in small font, it says interface. In the future, it's highly likely that you may come across another component in Android that is also an interface. So at this point, you may be wondering, wait a minute, how is an interface different from a class? The document pages look pretty similar. Well, in the last course, we learned about classes like TextView, which contains state and methods that are fully implemented, meaning there are instructions in each method. Now, we are being introduced to interfaces, which contain no state, but it does contain method signatures. Remember that a method signature signifies the return value, method name, and input parameters. It ends with a semicolon, and there are no curly braces with the code in the middle for implementation of the method. This means it's an abstract method. An abstract method's implementation is intentionally left blank so that a developer like you who wants to use the interface can provide their own specific instructions for it. So it's like saying, fill in the blank for what you want to happen when this view is clicked on. There can be multiple abstract methods in an interface, but this example of the onClick listener interface only has one abstract method, the onClick method. In the future, we'll also encounter abstract classes. This is a partially implemented class, and it contains state, and some methods are fully implemented, while other methods are left abstract for someone else to define the behavior. So you can think of this as a continuum, where an interface is not implemented at all, an abstract class is partially implemented, and a concrete class is fully implemented. So how come an onClick listener is not a concrete class? And why isn't a text view an interface? And the same with the view group being an abstract class. The Android team made these respective decisions based on what would make it easier for developers like you to build an app. Every developer will need to display text on the screen, so they created a concrete text view class that accomplishes that. We can simply call methods to change the text in the view. So in this abstract class case, we want to standardize some behavior about view groups being a container of multiple child views. However, the details of how to lay out the views on the screen is left undefined for the subclass to determine. In this case, linear layout and relative layout are subclasses of the view group class. They each define their own rules for how views should be laid out on the screen. On the other hand, the Android team knows that many developers will probably want to customize the click behavior. It wouldn't make sense to provide default behavior for what happens when a button is clicked, but the Android team did want to standardize what the method call would be and the class type would be an onClick listener. Then they leave the logic inside the method for the developer to write themselves. So to summarize, if you come across a concrete class in Android, you can use it right away. If you come across an abstract class, you need to subclass this and then provide your own code for the abstract methods. If you come across an interface, you need to provide for all the abstract methods.